tremendous progress. And here you can see just some examples where we take one of our environments and use one of these diffusion techniques, text fusion in this case, in order to generate textures for our models. Okay? So the idea is that as we do this, and as these techniques are also getting better and better, we can make the data that we generate more and more realistic, so that the sim-to-real gap is becoming smaller and smaller. So now we are kind of ready then for the whole system, right? We can generate all the data, we can generate what the solutions will look like from the robots perspective, and then we feed it into one of these large transformer models that will then train to replicate that behavior. And I gave you one example, this perceiver-actor technique, for example, with this 3D voxelization and the follow-up work, RVT, that we're going to train on that model then as well. You have to stay tuned, it's not done yet. We're still figuring out some of the details. As you can imagine, putting up the infrastructure for all of these pieces is quite an effort, making sure that the physics simulation works correctly. But we're very close to being able to really kind of train these large-scale models on that, and I'm very excited to see how far we can get with this. But again, the idea is we want to train them so that we can just put that robot in a real environment, an unknown kitchen, for example, and just indicate which drawer it should open, and just say open it, and the robot knows how to do that, even for unknown drawers in kitchens and objects. So with that, I'm going to come to my conclusion. I think we all agree that especially the NLP and the computer vision community have really demonstrated that if we can train models on very, very, very large data sets, that now we have actually the capabilities via, for example, transformer kind of models, that we have the capabilities to train models that are surprisingly broad in their reasoning and understanding, and also across a very broad set of environments. And I think that this reasoning is, of course, they're extremely strong already about reasoning on images and language, and about reasoning, I'm sure there's various people here who would say that the reasoning is still very limited and there's no real planning, and I agree, of course, on many of these limitations, but at the same time, I must say, I'm often just blown away by the results I see coming from these techniques. So I think in robotics, we still have to replicate that success, and people keep on coming to us and say, oh, why is it not working for you? What is this doing? It turns out it's really difficult. Robotics is still not a simple problem, and I think it's kind of like this AI complete problem if we can solve that. And the key problem is, as I see it, is we have, I think, now the kind of transformer models that are able to learn very complex tasks even for robotics, but we don't have the data yet. And I'm advocating that I think a simulation at least has a chance of providing that kind of data, at least in which we can train these first tasks that give robots the ability to also keep on training them later on in the real world. Finally, of course, doing simulation has huge advantages for things like benchmarking. It's much easier than benchmarking in the real world, and it makes it also much easier for non-roboticists, like for example AI researchers, to participate in that research, because you don't need your real robot and you don't need to take care of the hardware and all the costs. So I think we are actually on the verge of really bringing these different pieces, control, perception, and higher level reasoning, all together using these large-scale models. And I want to invite the AI community really fully engaged in robotics. I think yesterday I saw Christian talking about the submission numbers and how many papers we have from the different areas. And at the very bottom, we saw robotics with 4 papers here at IJCAI. And I would hope that we can increase that number again, also taking advantage of these new systems and capabilities that I described here. And with that, I'd like to thank you. And also, I'd like to thank, of course, the incredible collaborators and mentors I had throughout my career. It started at the University of Washington, at the University of Bonn, and then also I did my postdoc at Carnegie Mellon University, then worked at Intel, University of Washington, and now half-time at NVIDIA.